Hey guys, let's take a look at number 5 of 2021 AP Chemistry for response question. So you guys see the question. So there's a molten magnesium chloride, can be decomposed into its elements as sufficient voltage is added, applied into the electrodes. So as you can see from the diagram, okay, as there's some Mg accumulated magnesium metal accumulated here, and there's some Cl2 gas produced in the molten MgCl solution. So question part A is asking, draw an arrow on the diagram so that direction of the electron flow through the external circuit as it operates. So now, as you can see, this side where Mg2 plus is being what? Reduced to magnesium solid. That's a reduction process. Reduction is gaining electron. And now Cl minus is turning into Cl2, gas. So that's an oxidation process. So which means electron must travel from where the oxidation occurs and goes to where the reduction occurs. So the arrow should be going from what? From the anode to a cathode. Okay, this is a counterclockwise direction for part A. That's a point there. In part B, the question is asking, would the applied voltage of 2 volts will be sufficient for the reactions to occur? Support your claim with the calculated as a part of the answer. So if you write the equation, magnesium 2 plus aqueous, gaining 2 electron turns into magnesium. Very, very non-spontaneous process. If you look at the value for the voltage value, negative 2.37 volts. Very non-spontaneous process. Okay, it's not, which means it doesn't really happen on its own. So, and also 2 chloride ion turns into what? Cl2 gas, produce 2 electrons, negative 1.36 volts. So now if you add these two equations, you get this, which is the reaction you're looking at, which is magnesium 2 plus turns into magnesium solid, Cl minus turns into a Cl2 gas, and you have to add the voltage values. It becomes what? The total voltage value for the cell becomes negative 3.73 volts. Okay, so now they're asking, will the 2 volt of the voltage of the battery, will that be enough? So if you add 2 from this number, what happens then? It'll still be negative 1.73 volts, even with the 2 volt battery voltage. Is that sufficient for the reactions to occur? I don't think so. Because, as we know, this has to do with the spontaneity of the reaction. So based on the equation that I put here, in order for the reactions to be spontaneous, delta G must be a negative value as standard state. Okay? And now, in order to do so, delta G at standard state is equal to negative N, number of moles electron transferred, Faraday's constant, times what? These are positive values, times what? The voltage value. The voltage value must be, or electric potential must be positive in order for delta G to be negative. Which means to make this entire process positive, the voltage of the cell or the battery here must be greater than what? The battery voltage must be what? Greater than positive 3.73 volts in order to make this entire cell with the positive voltage. So would this happen? So the question is asking, okay, so would the 2 volt battery enough for the reactions to occur? The answer will be no, because the battery voltage must be at least positive 3.73 volts to support this reaction, to make the entire electric potential positive. That'll be the answer for part B. Part C, question is asking, if the current in the cell is kept constant at 5 amp, how many seconds does it take to produce 2 grams of magnesium at the cathode? So they want to produce 2 grams of magnesium. And they provide you that, okay, so we have a current is equal to 5 amps. 5 amps is equal to what, guys? 5 coulombs per second. Okay, they're giving you, they're supplying with the 5 coulombs per second as a current. So they want to produce 2 grams of magnesium. They want to find out, okay, so if I give this much charge per second, how much time it will take? So the equation is, okay, the equation is what, guys? Mg2 plus 2 electron turns into magnesium. for 1 mole of magnesium to be produced, they need 2 moles of electron. So which means we have to convert the grams of magnesium to moles to have a better understanding. So first thing first, what I will do is I'm going to multiply this by the molar mass, or convert this to moles of magnesium. So 1 mole of magnesium is equal to 24.3 grams of magnesium. So the grams of magnesium cancels out. So if you multiply up to here, you get what? Number of moles of magnesium. And now, as we know, I need to find out, okay, how many moles of electron needed to produce 2 grams of magnesium. So, okay, so from what the equation says, for 1 mole of magnesium, I need to put in 2 moles of electron, okay, from the equation, right? So up to here, if you multiply to here, you'll get you how many moles electron is needed. And then, okay, so I mean that's not really enough because I need to figure out, okay, so this one is given as in coulombs, the charge, okay? So I gotta convert, okay, so this many number of moles electron that I need, how much charge is that? There is, guys, something we call Faraday's constant. So 1 mole of electron is equal to what, guys? Now around 96500 coulombs of charge. Okay, so now this will tell you up to until this point is what? It will tell you how much charge do I need in electron. So then also, then what happens then? Okay, so I need the answer in what? In seconds. So that's what the current is. So I'll have to apply that. Okay, so in 1 second, they're providing what? 5 coulombs of charge. Okay, I just have to, like make it reciprocal value, right? And the coulombs will cancel out. And what happens? You just have to multiply the values and you get your answer. You've multiplied out, guys. I got the answer as around 3,176.9 seconds of the current should be applied with 5 amps in order to produce 2 grams of magnesium. So make sure to understand, guys, sometimes they will ask, if the time is really long, they will ask, oh, how many minutes or how many hours. So make sure you after you get the answer, oh yeah, I got my answer, that's it. Now, like, make sure you check the units. If they want in seconds, give them in seconds. If they give in minutes, give them minutes. So be watch out for how the question is being phrased for a question like this.